Hey guys, how's it going? My name is Adeel Malik and I am a fellow student in your Gen Chem 2 class. Today I will be presenting on the Egyptian night experiment. So this is a classic experiment that has been around for quite some time now, and it's called a chemical clock reaction, specifically because there's a series of chemicals that react and a known occurrence results after a certain period of time has passed. In this case, it forms a dark solution after you mix two transparent ones, which I will show you in the overview again. As for the reactants that are involved in this experiment, starch, potassium iodide, sodium thiosulfate, hydrogen peroxide, and acid. It can be sulfuric or acetic, whichever one's most conveniently available, water, and of course you need 2 beakers and a stirring rod to conduct the actual experiment. As you can see here, this is going to be the initial, and that is going to be your final product after the entire reaction is complete. And it's called the Egyptian night reaction because the solution at the end resembles a typical dark Egyptian night. Before I get on to the video, I'm going to make a brief note about safety, as we all know how important that is. Always remember your PPE, guys. So wear protective glasses and gloves. Avoid touching the hydrogen peroxide or the acid onto your skin, or ingesting it, or touching your eyes with it. And always, always, always follow general safety recommendations. Here's a quick look at the main reactions. The first one is a very slow step, which involves a reaction between hydrogen peroxide and iodine ions in the presence of H+, which eventually forms the molecular iodine. The second reaction is the faster step, which occurs between iodine and sodium thiosulfate. Alright, I will now show you the video of the actual experiment itself. It has some really good captions, so hopefully you won't need me to talk over a whole lot. Now they're going to add vitamin C, and the solution is going to result in a clear step first, because it reduces the iodine ions. The starch is the actual indicator, which results in the color itself, so without that you wouldn't really see much. And there it is. Alright, now that you've seen the actual reaction, I'm going to go into a little bit more detail. So this is actually a first order reaction, and it involves a succession of parallel reactions, which starts with the oxidation of the iodide ions by the hydrogen peroxide and then producing the molecular iodide. This iodine then reacts with the sodium thiosulfate until the sodium thiosulfate is completely gone. Although there's no more sodium thiosulfate to react with, there is excess iodine still present in the actual system, and this then proceeds to react with the starch in the system. And the starch, being the indicator, is what allows the actual dark blue color to occur. Here are some steps, well, the 2 main steps just shown as chemical reactions. As you can see here, hydrogen peroxide reacts with the iodine and the hydrogen ions in the first step, resulting in the molecular iodine right here and some H2O. This is an overall very slow step. I heard it's about 8 times slower than step 2, but that's just a ballpark figure. In step 2, the sodium thiosulfate reacts with the iodine at a much faster rate than any other step. And as you can see here, the final resulting product after the starch solution has been added, this is what's going to give you the actual dark blue color. And that's it. So if you guys have any questions, feel free to let me know in the comments below, and I will get back to you as soon as I can. My name is Adeel Malik again, and thank you so much for watching my presentation.